Good evening, students. Today our topic is context-free grammar to PDA conversion. So this is a part of pushdown automata. So before going to this topic, we see about what is context-free grammar. In last video, we see about what is context-free grammar. This is a slide for context-free grammar. So here I give the definition for the grammar. It's a collection of verbals, terminals, production rule and the starting symbol. This is known as a grammar for context-free grammar. So the context-free grammar have some rules to generate the strings. Now we see about the how to convert the context-free grammar to PDA. So the pushdown automata is same as the finite automata with the memory. That is known as pushdown automata. So the context-free grammar used to generate the context-free language. This language only accepted by the pushdown automata. So the pushdown automata machine accepts some language or grammar that are equal to the context-free grammar. Now we convert the context-free grammar into pushdown automata production. These are the following 5 steps are used to convert the context-free grammar into pushdown automata. The first is step. So convert the given productions of the context-free grammar into GNF. So GNF is nothing but Wayback Normal Form. So our production rule must start with the terminal or epsilon. That means, example, my production rule. For this example, see the example. This is the production rule of the context-free grammar. This context-free grammar must start with 0 and 1. 0, 1 means this is the terminal. It may be start with capital A or capital E means it start with the non-terminal. So we must change the step into terminal. The context-free grammar must start with the terminal. Small letter A, B, 0, 1 like that. Second step, the PDA. In our PDA, only one state are present. So the pushdown automata have the only one state, the state acting as a starting state. The third step, the initial symbol of the CFG. So what is the initial symbol of the CFG will be act as the initial symbol in the PDA. So first 3 steps are very important. The context-free grammars are given in sum. We convert the grammar or the production rule into PDA. So before starting this step, we convert the given CFG, context-free grammar, into GNF. GNF means the production rule must start with the terminal. The starting symbol is same as what the starting symbol present in CFG. That is the same initial symbol in PDA. Second one, the PDA have only one state, Q0. So these are basic steps. When go to the production rule, we divide the symbol into 2 concepts, non-terminal symbol, other one terminal symbol. So non-terminal symbol means capital A, capital B are known as a non-terminal symbol. This non-terminal symbol must not be empty. So we write the production rule. We write the PDA rule like that. So transition, state name, epsilon, input is epsilon. Here the terminal name is tends to Q, alpha. This is the rule number 1 for non-terminal symbol. Second rule for terminal symbol. What are the or how many terminal symbols are available in the CFG? We write the PDA rule. Transaction Q, A is tends to Q, epsilon. because the PDA have three states. The first one The first state point to the state, transaction state name. The second A point to the input symbol. The third A point to the stack symbol. Okay, this rule applicable for only PDA. The right side, the Q represent the new state comma epsilon. So this two rule is enough to convert the given context free grammar into PDA. Now see one example. This is example number 1. Convert the following grammar to PDA that accept the same language. So here we give the two production rule S and A. So S start with the terminal 0, S1 or A. The second rules A followed by 1, A0 or S or E. So what is our first step? So first step is simplified by eliminating unit productions and the terminals. Okay. So what's the concept of unit production? It's nothing but S tends to E. S tends to E. That is known as unit production. So now we will convert the context free grammar into GNF. S tends to 0, X, X, 1, XY. Here the 1 is replaced by X and the 0 is replaced by Y. That is known as unit production. So the first step, S tends to 0, S, X. So 1 pointed by X. So here I apply the X in the production rule 1. To apply Y for 0. Here I create two variable, X tends to 1, Y tends to 0. So this is known as all the grammar rule must start with the production rule 0, 1, 0. So the first concept is done. Second step, so before going to this, we have number of terminals 2, 0 and 1. The non-terminal S, X, Y. This is our non-terminal. Capital letter S, capital letter X, capital letter Y. So these three symbols are acting as a non-terminal. 1 and 0s are acting as a terminal. So directly you write the production rule for terminal and non-terminal. The rule number 1, write for the production rule S is the starting symbol. The S value have three values. The first value 0, S, X. Second value 1, S, Y. Third value E. So Q is the only one state that present in the pushdown automata. So this is the input, this is the output state. So here see the previous slide. So what's the value of S? The S value have three values. 0, S, X, comma 1, X, comma Y or E. So I write the starting rules for S with three values. The state Q 0, S, X, 1, X, Y and E. So this is the production rule for S, starting symbol S. My second production rule X. My third production rule for Y. So X tends to 1, Y tends to 0. So refer this one. This is our formula. This is our formula. So we write the rules for non-terminal symbol Q, comma empty. Epsilon mean empty, comma so A. A tends to alpha. A tends to alpha. Here X tends to 0. Y tends to 1. X tends to 1. Y tends to 0. Here we apply the rule. Q is only one state. The input is empty. X tends to 1. Third rule for Y, Y tends to 0. So the first three rules for non-terminal. The rule number 4 and the rule number 5 for 0 and 1. So what is the rule for terminal? Here this is the rule for terminal. q comma a is tends to q comma epsilon. So very simple. A comma a is tends to epsilon. Here my input is 0 and 1. So I write the rule number 4 for 0 and the rule number 5 for input 1. So 0 comma 0 state name q empty, 1 comma 1 empty. Here you can write epsilon. So e is nothing but epsilon. So this is the PDA rules for the given language. So in sum, they give the starting symbol, the terminals and the verbals are given. You convert the verbals and terminals into as a PDA rules. Okay, we follow two rules, the one for the terminal and the one for non-terminal. Now go to example number 2. Construct the PDA for the given CFG and test whether 10 power 4 10 power 0 is accepted by this PDA. So the production rule is given. So the starting symbol is S. S start with 0 BB and one more rules for terminal B is tends to 0 S 1 S 0. So here the left side we have only non-terminals. This non-terminals started by terminals. Terminals mean small letter A comma B 0 R1, that is known as terminal. On left side we have only non-terminals, that is we have only non-terminal capital letter A comma B S. Okay, the two rules are given. The two rules are in the format of CFG. Now we convert the CFG production rule into PDA. So the PDA given, this is the starting state or only one state is name of Q. The input is 0 comma 1. So already I told what is PDA. So PDA have a extra memory placed in the name of stack. The third parameter S comma B comma 0 1, that is known as stack symbol. That is known as stack symbol. Transaction rules. Now we go to find. So Q is my ending state, S is my starting state. Now we go to find the production rule for terminal and non-terminal. So for terminals, so what are the how many terminals are present in my context free grammar? 0 and 1. One more terminal is epsilon. One more terminal is epsilon. Here I accept the terminals because the epsilon also considered as one of the terminal. The rule number 1, we write the rule for starting symbol S. So S tends to 0 BB. So here I write S tends to 0 BB. So the S present on left side and the value or the variable present on right side. S tends to 0 BB. The second rule for the non-terminal B, we have three values as in the sum. B tends to 0S, 1S and 0. So here I write three rule for non-terminal B. State is same, Q comma 0S, Q comma 1S or Q comma 0. This is the PDA rules. Now we complete the two production rule for the non-terminal. Next I take the terminal 0 comma 1. So 0 comma 0 is epsilon, 1 comma 1 is epsilon. These four rules are present in PDA. The last step, you check the given string is accepted by PDA. So the given string is 0, 1, 0 power 4. 1 0 power 0. So the 4 can be expanded as 4 zeros. So Q is my starting state. The input is 0 1 0 0 0 0. Starting stack symbol yes. Okay. So now we apply the rule, PDA rule in this grammar. So S tends to 0 BB based on the rule value 1. So S tends to 0 BB. Here we apply the value. So starting symbol, stack symbol S can be changed into 0 B B. Next, in the input stack and in the input and the stack, the starting states are 0 0. We cancel the 0 0. So next to one, remaining output 1 4 0. Next, we apply the PDA rule for the value of B. So B tends to, listen, B tends to 1s. B tends to 1s. Here the first B is converted into 1s. The remaining B is presented. The remaining B is forward. Next one, both input symbol and the stack symbol have 1. So the 1 is popped. Both stack and input symbol are same. You can pop the element. The remaining input is 0 0 0 4 0. The remaining stack symbol S B. Again you apply the S value 0 B B in rule number 2. So the S converted into 0 B B. So the same process is repeated. So first stack symbol and the input symbol are same. You can pop the symbol. So we try to substitute the value of S and B to get what are the element is present in your input. So we convert the B value into 0 B, then pop the 0. Again you convert the B value into 0 B. Again you pop. So everything is popped. There is no element in the stack. There is no input in the input tag. So the finally both input and the stacks are empty. That means the given input string is accepted by the PDA. Thank you, students.